Welcome to this tutorial on Kubernetes Node Selectors. This is part of the Kubernetes Scheduling series, where we explore how to control where your pods run in a cluster. Node selectors provide the simplest way to target specific nodes using labels. In this video, we'll understand what node selectors are, how they work, and when to use them. A node selector is a simple way to constrain pods to run only on nodes with specific labels. It uses a label-based matching mechanism to determine where pods should be scheduled. Think of it as the simplest form of node selection in Kubernetes. Instead of letting the scheduler place your pods randomly on any available node, you can specify exactly which types of nodes should host your workloads. There are several practical scenarios where node selectors become essential. First, for hardware requirements. You might want to schedule pods on nodes with specific hardware like SSD storage or GPUs for performance-intensive applications. Second, for environment isolation. You can separate production and development workloads to prevent them from interfering with each other. Third, for resource optimization. You can target specific node pools or instance types to make the most efficient use of your infrastructure. The node selector workflow has 3 simple steps. First, you label your nodes with key-value pairs that describe their characteristics. Second, you specify the node selector field in your pod specification, indicating which labels you're looking for. Third, the Kubernetes scheduler reads these requirements and matches the labels, placing the pod only on nodes that have all the specified labels. Let's see how to label nodes in practice. To add a label to a node, use the kubectl label nodes command followed by the node name and the label in key=value format. For example, kubectl label nodes node-1 disk type equals SSD. This assigns the label disk type with the value SSD to node-1. To verify that the label was applied correctly, use kubectl get nodes with the show labels flag. This displays all labels associated with the node. Now that the node is labeled, let's create a pod that uses the node selector. In your pod specification YAML file, add the node selector field under the spec section. The node selector is defined as a set of key-value pairs. In this example, we specify disk type :SSD. This tells Kubernetes to schedule this Nginx pod only on nodes that have the disk type equals SSD label. The scheduler will match this requirement with the available nodes. Node selectors support multiple labels, and it's important to understand that all labels must match for the pod to be scheduled. This is AND logic, not OR. In this example, we're specifying 3 labels: disk type :SSD, GPU :true, and environment :production. The Kubernetes scheduler will only place this pod on a node that has all 3 of these labels. If even one label is missing from a node, the pod will not be scheduled there. While node selectors are simple and effective, they do have some limitations you should be aware of. First, they only support exact equality matching. You cannot use or not operations to create more complex logic. Second, if no matching node exists in your cluster, the pod will remain in a pending state indefinitely. Third, node selectors cannot express complex scheduling rules that involve preferences or priorities. For advanced scenarios like these, you should consider using node affinity or taints and tolerations, which offer more flexibility and power.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.